All right, so once you have your crystal, you're gonna pack your crystal into the capillary tube, look like that. Your TA will teach you how to do that, okay? And you're gonna insert this capillary tube into what we call melt temp. Okay, some of you might have seen this lying around on the counter before on the bench, okay? So on the left side is the analog one. On the right side, this one is the digital one, but both works, okay? Both of them work just fine. Inside right here, there's a sample holder, or we call capillary slots. There are 3 slots. That means that you can do 3 capillaries at the time. Okay, you're gonna look through the magnifier right here. So there's a magnifier right here, and you're gonna say something like this. You can say there are 3 slots. Okay, so I'm gonna show you. So this is what you expect, right? On the left side right here, this is empty slot, so nothing there. Okay. In the middle is a capillary filled with solid. Right? If you see right here, you feel this is magnifier, so everything's bigger than normal, right? The amount of solid you put in here really small. Do not add as much, right? If you add too much, it won't melt like at similar time, and your melting range is gonna be too broad, right? How long? Usually about the tip of the capillary tube. The TA gonna tell you how long it should be. Okay. All right. Basically, this is solid. All right. This one is not melted yet. On the right side, that's completely melted. You're gonna see a little bit look like water right here. See that look like water at the bottom and up top. So this is a liquid right here. Okay. So when you start, you look like that. There's your capillary tube. You look like that with a solid. When everything's completely melted, that's when you see water look like that. Okay. So what do you have to record? You're gonna record when this solid start to melt, right? They describe like this. So when the solid start will become sweaty. I don't know how the better way to describe that. You're gonna start seeing like a liquid at the top, at the bottom, or in the middle, something like that, right? They call it sweaty, right? That's your first melting point, right? And when it's completely melted, that will be the final temperature. You record that as well. Okay, let's say I take a crystal, add to in the capillary tube, put into the melt temp, and I got initial temp and final temp 68, 71. 68 start melting, and 71 is everything completely melted. Okay, this is my melting range. Right, you're gonna report this melting range to your lab report, basically. Yeah. Now, what do we use melting range for? Right? If you remember, pure compounds have a sharp melting range. We allow about 3 degrees apart, right, from when it starts melting and completely melted. But in theory, it's only 0.5 to 1.5 degrees apart. Okay. Impure compound have broad or depressed. All right. Okay. Another way to use melting range to confirm, right, that that's actually bithenyl or that's actually your compound. We call this technique. Look right here. Okay. All right. I'm gonna have you guess what's going on. All right. My question is, well, if my that crystal of mine actually bithenyl or not? Okay. So that's the question we try to determine. I'm going to take an authentic or pure bithenyl sample, so we know that's a pure compound. All right. And then I'm going to make this too, like into a test tube, just a little bit. That's not a lot. Well, take some of this of the crystal and take some pure bithenyl and then pack into the capillary tube. Basically, if my compound is bithenyl mixed with bithenyl, this is basically pure compound, right? So this is a pure bithenyl in here. If I take a melting range with a melt temp, how would you see the melting range? Is it broad, depressed, or sharp? Well, pure compound give you sharp melting range. Okay. Let's say if my crystal is not bithenyl, let's say it's benzoic acid, right? Also a white powder or white crystal mixed with authentic bithenyl sample. This is pure bithenyl. Whatever I pack into capillary tube, that's not pure. Put into the melt temp, what happened to the melting range? Broad or depressed. Okay. This technique is called mixed melting point or mixed melting range. You're gonna do that. Yeah, this technique will help you confirm that's a bithenyl. That's the compound that you're looking for. Okay. All right. So basically, what you're gonna do in the lab. Okay. All right. Let's talk about this on the next video. I'm just gonna summarize everything what you will do.